Hello and welcome to our project demonstration for Verne VR. First, we'll take a look at the starting scene that players will find themselves when they start the application. It's a nice scenic outdoor location. And first, I'll bring your attention to these grabbable objects. You can reach down and press the trigger button in order to lift them up. You can grab one in each hand, and you can even stack them on top of each other while you grab it. Very useful for any implementation that would require grabbing, but for now we have the features. Next, I would like to show you our modules. Right now we have a slot for quaternions and motion sickness. So first, let's take a look at the quaternions module. I can simply point towards it and then click the A button and then I'll load into the module. The quaternion module has this nice scenic park, but let's get to the actual meat of the application. The goal of this application is to rotate this object on the left such that it looks like the object on the right. And you do that by inputting 4 component quaternion values into a menu. So hopefully through this, students will learn how to use 4-value quaternions in order to implement their VR applications. So in order to show this, we're going to click Easy. Easy approximately has 1 rotation in order to do before you get to your target, so let's see it. I'll click Start. So right here, it rotated about this axis. I believe this is the this is the x-axis actually, and it's 90 degrees, so that corresponds to this quaternion rotation right here. Let me go back. Pi over 4 sine. If I do cosine right here, and I click apply, it goes to the correct orientation, and I get a score +1 because I rotated the object to the left to look like the right. So now let's do it this one. This is the y-axis. So this rotation corresponds to 90 degrees around the y-axis, which corresponds to a quaternion that looks like this. Hopefully I got it right. And there we go. My score went up by another. And through inputting these values, hopefully students will get a better understanding about how to assemble quaternion rotations just by doing them. So now we have the results menu. You can see the time elapsed as well as the score we got. We got 2 correct, therefore my score is 2. Now, greater difficulties jumble up the target a little bit more, which we can see right here. That one was a bit simple, but let's you can see this is a lot more complicated of a rotation. It might require more than 1 step, and students might have a more difficult time doing that. So hopefully students will learn quaternions by doing that. Next, we'll show you our implementation for a UI dialog text, which we will present information to students using. You can click the next button in order to go to the next menu on the dialog text. You can click the back button in order to go to the previous menu. Right here, text scrolls on the screen as you click each button, and then we hopefully will use this information in order to present information to users in each module, such as through the motion sickness module, which will require some information that we will have to give to the users about what they're supposed to be learning about how to prevent motion sickness and best practices in order to make sure users are comfortable. Now we'll return to the hub. For our future plans for the project, we hope to make the quaternion module more streamlined and easy to use so that users have a better time navigating through the menus and inputting quaternions so that they can have a better learning experience. We hope to implement the motion sickness module, as well as implement modules as time permits, including maybe a module for graphics rendering, light and reflection, or VR locomotion. This concludes our project demonstration, and we hope this application will be useful for users in the future.